So as you heard, I'm Cameron, and I'm the product lead for the Go team at Google. I've been a PM on the Go team for around 2.5 years, but I only took over from Steve Francia as product lead earlier this year. Steve has some huge shoes to fill in this community, which has some pros and cons, but most of all, I'm grateful, and I think we're all grateful for the tremendous momentum he's generated for the Go project. So today I'm going to talk to you about the Go developer experience. We can think of Go and the tools around it as freestanding pieces, but we actually put a lot of thought into how these pieces intersect. Um, I want to tell you about that and the sort of holistic developer experience we hope to create. And at the end, I'll touch on some stuff we're working on now and how it all fits in this broader vision. So I said developer experience, which might sound straightforward. Good developer tools, documentation, stuff like that. But when we try to apply it, it actually has some depth. This quote, I think, captures it at its highest level. Developer experience is about creating an environment in which a developer can do their best work. It should consider every touch point a developer interacts with to plan and produce software. Building on that latter point some more, the bit about accounting for developer touch points is this quote from Sarah Drasner, who's a director of engineering at Google. She writes that the key to thinking about developer experience is thinking beyond a single product, which in turn means prioritizing the features that are touch points along the larger system, the steps in the larger developer journey. That description is one of the best I've found, and Sarah accompanies it with this diagram to help explain. Imagine a product in isolation, where each of the features of this product are all basically equally important. Now, in reality, developers aren't just using one product when they plan and write software, so the developer journey actually spans multiple products. Think the IDE, the docs, the debugger, command line tools. And what Sarah is saying is that when we think about developer experience, it's these touch points across products that make up the developer journey. By prioritizing those touch points, the intersections in the multiple products the developer uses, we optimize the experience as a whole. So I think that's a good description of what we mean by developer experience. Sarah's definition implies thinking about developer experience holistically across products. But I want to zoom out even more, from before our developers ever get started with Go, all the way through when they push their code into production. And what follows is my framework for thinking about this broader journey, inspired by Sarah, but also really some other really smart folks in the community. And it's got 3 steps, beginning with what I call curiosity. Curiosity comes before everything else, possibly before a developer even knows anything about writing code. This is where she forms her earliest impressions of the product, in this case, a programming language. She's going to hear about the language's use cases, its community, its thought leaders, the language's broader philosophy. And if our developer's curiosity is sufficiently piqued, then she'll go further and try it out. Maybe she'll end up writing a hello world on the playground we make available on go.dev. This is what I call onboarding. Our developer has bought into the vision, and her attention is now ours to lose. If she's able to learn more, try more, she'll find its value. Assuming there's value to be found, of course, but as we all know, there is very much value to be found in Go. And finally, we have step 3, what I call usability. This is where all of you probably are today. You've onboarded successfully, and now the experience shifts to long-term productivity and usability. Now our objective is to delight you, most of all by making it easy for you to use Go to achieve your purpose. And this is where that intersection that Sarah described is going to be especially significant. So I want to dig into each of these stages a little bit before we get into it for Go. We'll start at the top with curiosity. When we zoom into curiosity, the first thing that I think of is the language itself. And by that, I mean the innovations of the language or its broader philosophy that invoke curiosity and interest in learning more. Next, I think of community. There are probably many of you here who learned of Go by word of mouth or in a tweet or because someone you trust likes it. This event itself, GopherCon, is evidence of the dedication of Go's community and is a strong driver of curiosity for the uninitiated. And finally, I have here what I call inspiration. This might be case studies where you learn of a team somewhere else using Go to solve a similar problem that you face, or it could be job opportunities, or it could be general marketing. Whatever it was, you were inspired to learn more. So next we'll zoom into onboarding. Again, we've already captured your attention. Now we want to light the path to getting you started. This is going to include things like documentation. You want to browse the manual, see what's possible. And a similar but slightly different component is the resources you find for getting started. This is the on-ramp to getting the pieces of your development environment together and beginning to make something useful. And finally is what I call education. Documentation and getting started show you what's possible and get you going, but actual educational resources are what drive you to learn more. Think of things like the workshops we had here on Thursday, or books or tutorials or blogs. This is where you begin to really build up your Go muscle, gaining exposure to the things that really make clear how to productively use Go to create real value. And again, back to usability. I'm going to spend the remainder of this presentation on this last stage here because it's where most of you are today, and it's where I think our story is the most interesting thus far. One piece of this usability stage is what I call integration, and I mean it in that Sarah Drasner sense. How well do the products in the Go developer experience integrate in order to create for an optimized, productive developer journey? Next is what I call maintainability. We'll dig into these pieces some more in the slides to come. But generally what I mean here is, how sustainable is it to use Go in production and in day 2 and beyond? And finally, we have the ecosystem. Here, we're thinking about things like the libraries and building blocks of a Go application. This is arguably the most important piece of the whole thing, and it's the hardest to achieve because it's largely up to you, the community, to build it. But we also have a unique role to play as well, and I'll explore that in the next section. Okay, with that framework out of the way, let's break into that last stage, usability, and describe how the Go team thinks about the broader Go experience. Remember that first stage we identified is what I called integration. And the point here can sort of be summarized as making the whole greater than the sum of its parts. And integration really can be broken down a bit more into the idea of, first, product integration. How well do the different subproducts connect to form the bigger product? And then second, journey integration. How well do those subproducts integrate to create entire user journeys? In this integration point, the example that first comes to my mind is Apple's consumer experience. Apple leverages integrations in combination with things built by third parties to power its user experience. So looking at the iPhone, for example, Apple digs backward into the value chain to build its own silicon, which is this fundamental subproduct that creates the foundation for everything else. Then on top of it, it has iOS, which it integrates deeply with the specialized SoC underneath. Looking further up the stack, they rely on a community of third parties to build the applications that make the iPhone what it is. But they also maintain the App Store, which is that customer-facing link in the value chain. This sort of product integration has enabled Apple to do really differentiated things that make it hard for less integrated alternatives to compete. And on the other end of the integration point are these journeys that Apple is able to create via its cross-product integration. The iPhone and Watch and AirPods, they work so well together that you feel you're buying into the whole experience, this holistic consumer experience. And I'll take a second just to mention that I don't use an iPhone. I'm a huge fan of Google's Pixel, and I just bought the Pixel Watch on Thursday, but I admire Apple's brilliance here. All right, so enough about Apple. What about Go? Go has a portfolio of products that integrate with each other and create journeys as well. Our simplest, but still incredibly important product is Go.dev. Next, we have the Go command itself. It's simultaneously powerful and simple to use. We have the Go IDE plugin and the Go Please language server. We have the package site where we aggregate the whole Go ecosystem into this uniform sort of Go tailored presentation. You can think of this a little bit like Go's App Store if we're to compare it to the iPhone example from before. And most recently, we also have the Go Vulnerability Database and Vulnerability Management System, which I will touch on some more at the end of this presentation. So let's take all that and we'll plot it on this highest level developer journey. So after getting started, we can think of the sequence from planning to building as this loop of development activities that you use for planning and writing software. First, to get started, you go to go.dev, where you can try out Go and download your tools. When you're planning your approach, you're going to start looking at third-party libraries available to you, which bring you to package.go.dev. To write your code, you can use Golang or something else, but you can also use our Visual Studio Code extension. And by the way, I should mention that it's simultaneously important that tools like Golang exist and thrive for the folks who like them, and that we're able to provide a free open source alternative like VS Code Go as well. And that's because it's the only way that we can ensure that the end-to-end experience is integrated. For example, imagine a world where we didn't own the VS Code plugin, and say we release generics, but third-party editors are slow or reluctant to expose it in their products. That would make it incredibly difficult for us to account for the end-to-end generics experience. So next, let's say you want to troubleshoot, so you look up the docs, make those available and easy to work with on go.dev. And you want to test, which means using Go test. And the latest addition to this portfolio is the ability to detect and fix vulnerabilities in your code or your dependencies, and we'll touch on this in a bit. But we make available the new Go Vuln Check tool at the command line. And this is also, and we also make integration with VS Code Go and Go Please and the editor, and integration with package.go.dev, all the developer touch points where this sort of information is valuable. And finally, you build with Go, and then you start all over again. And the point is that throughout, we've been thinking about how to ease this journey and emphasize all those touch points between the products that make up the Go experience. The next notch in the usability section is what I call maintainability. Maintainability here really means two fundamental problems of scale. We'll call them system scale and engineering scale. Let's start with system scale. Here's what I mean by that. Systems are getting larger and more complex, and in that context, ensuring that your system can scale to meet demand now and in the future, you require performance and you require resilience. And of course, one of Go's hallmarks is its capacity to scale up and down gracefully in this sort of systems context. I like this quote from a Netflix tech blog, which I think sums it up. The decision to use Go was deliberate because we needed something that had lower latency than Java, where garbage collection pauses are an issue, and is more productive for developers than C, while also handling tens of thousands of client connections. And among the major languages, this is how we position Go and the work that we do. More performant than all the dynamically typed languages and close to what you see when you get close to the metal in something like C or C++, but without compromising developer productivity. And resilient too. You heard Russ speak to the compatibility promise at the start of the conference, and he closed with that sort of bold directional statement where he said, there will never be a Go 2. Go programs will never stop working. That's more important. And in the security discussion I'll close with, you'll see that our latest work in the vulnerabilities management space is largely about resilience as well. We want Go to not only be the most stable platform, we also want it to be the most secure. So the next scaling problem that I mentioned is engineering scale. And the idea here is that programs and software teams are getting larger and the rate of software change is increasing. Go's emphasis on productivity, readability, simplicity, its test framework, these things are all meant to encourage developers to write good code, which together make you and your teams more productive. Max Kanat Alexander, who used to maintain Google's engineering practices documentation, wrote this in his book. The chance of introducing a defect into your program is proportional to the size of the changes you make to it. This observation, I think, is really an argument for reducing complexity. That's a huge part of a software engineer's job. And the Go team's job is to make the software engineer's job as easy as possible. And that's in part what we mean here when we say that Go's engineering scalability makes it maintainable. The easiest example, of course, is just how easy Go is to learn. There aren't a million ways to shoot yourself in the foot. That's one of the very core principles upon which the project was founded. And when you read Go code, you often can't tell who wrote it. I think the value of that in terms of engineering scalability really can't be overstated. Go is a test framework built in, which encourages you and your team to write good tests. And things like cross-platform compilation, single binaries without a separate runtime, fast startup time, all make it really easy to build and deploy at scale. Plus, they make Go readily usable in a wide swath of use cases, from small serverless deployments to full-fledged platforms like Kubernetes. And last but not least is the developer satisfaction that we see from Go developers. Go is consistently in the top languages developers love and want to use. And that means a lot for engineering scalability. It's important to the culture of a company, to recruiting and retaining talent, to keeping things satisfying and ultimately maintainable. Which brings us to the last dimension of usability, Go's ecosystem. Go's ecosystem is really composed of both the libraries and packages you can find on our package site, as well as the people who build those libraries or contribute to the Go project. It's important to point out this is expressly not us, it's you. But we are uniquely positioned to ensure that the ecosystem is stable, secure, and that its culture is healthy. We really want to incentivize Gophers to deliver the highest quality work possible while being excellent to one another. So first we have our contributors, almost 1,900 contributors as of last week when I took this screenshot, and all the individual communities. Today, there are millions of developers who are actively using Go to build their applications. But even more significant than that, there are hundreds of thousands of Gophers around the world who meet up. They come to conferences like this because they love Go. There's a large, robust library ecosystem as well, almost 900,000 different modules. And of course, our package site aggregates it all in this clean, consistent interface that makes things easy to work with. So that's what we've done in all the ways the Go you use today is a holistic experience. And now I want to provide you a glimpse of something we're working on now and how I hope it lives up to all those principles I laid out. And that's our ongoing security work. So when we say security, we generally mean one of two things. The first is detecting and remediating known vulnerabilities in your dependencies. I'll start by describing the problem. Say you're writing this package A, and to do so, you depend on several other packages which provide some functionality. They, in turn, might also depend on packages as well, and so on. Now, let's say there's a vulnerability deep in your dependency tree. Deep and far away as it is, this vulnerability might actually have consequences for your project. And that's because the problem isn't isolated to package K. It could affect I, it could affect B, C, D, or E, and worst of all, it could affect you because of a problem in some leaf package that you've never even heard of. With the web of dependencies that rely on other dependencies getting larger and more complicated, there are lots of places for a bad actor to stuff a vulnerability that affects wide swaths of a language ecosystem. This is in part because dependency graphs can be complicated, making vulnerability detection and remediation intractable. You may think your dependency graph looks like this, but really it looks like this. Dependency graphs are complex. The rendering on this slide is Kubernetes. Okay, and I mentioned bad actors, but these sorts of problems can happen by accident too. I'm sure you all remember the log4j vulnerability discovered in the Java ecosystem late last year. In Go, we solve for this problem by addressing it for the whole ecosystem. With Go's new vulnerability management system, which is now in preview, you can check your entire dependency graph against our curated database of vulnerabilities and fixes. And now you might begin to see how this connects to the premise of usability and a holistic developer experience. We've integrated this experience across several developer touchpoints that are illustrated on the right of this slide. Package.go.dev, where you can learn more about the packages you use and whether they might expose you to a known vulnerability. VS Code Go and Go Please, where we shift the detection and remediation of vulnerabilities to the IDE before you rely on them. And the CLI via the new Go vuln check command, which you can integrate into your CI or otherwise use where you aren't actively writing code in your IDE. It's all integrated, it enhances maintainability and resiliency and developer productivity, and at the end of the day, it's all about the security of the Go ecosystem. You write the packages, but we're the stewards who are uniquely positioned to promote its security. Okay, now vulnerability management helps you detect and fix your exposure to known vulnerabilities, but what about undiscovered vulnerabilities, like the ones that might exist in the code that you're writing? For that, we have fuzzing, which Katie presented to us yesterday. And as a refresher, fuzzing is this process of testing your applications using automatically generated inputs that are derived from coverage feedback and other signals. It's really well suited for reaching those edge cases which developers often miss, which makes it particularly valuable for finding security exploits and vulnerabilities. Go supports fuzzing in its standard toolchain beginning in Go 1.18, which makes Go the first major language to support it natively. It looks something like this. You create a fuzz test, which can run continuously or as part of your CI or however else you'd like. If your fuzz test finds a problem, it automatically creates a regular test for you, which becomes part of your test suite so you can avoid future regressions, which, by the way, is another example of integrating across products. But what I'm really excited to point out is how all of this is integrated not just within one individual developer's Go experience or a team's experience, but across the whole Go ecosystem. By fuzzing your code, you find vulnerabilities in your code and in your dependencies, which you can then report back to the Go vulnerability database and make available to developers everywhere. And that creates this awesome end-to-end experience that not only makes your experience more integrated and maintainable, but it makes the whole ecosystem more secure. I think Go really sets the bar here for what developers should expect from their language ecosystems. So let's finish up with a recap of this holistic security experience. Recall the three principles of usability we set out: integration, maintainability, ecosystem. We say this experience is integrated because it accounts for all developer touchpoints. Vulnerability management is available on package.go.dev, in your IDE, at the command line, and fuzzing is connected to testing. And separately, it's all integrated through this broader security journey, vulnerabilities plus fuzzing, the flywheel on the previous slide. We say this experience is maintainable because it both increases your system resiliency, because it shifts security information into your IDE or the command line or package site, which in turn increases developer productivity and efficiency. And finally, we say that it strengthens the ecosystem by making it more secure. By aggregating vulnerabilities as only we can and encouraging more secure practices as only we can, we make it possible for you, the developers, to create a more secure ecosystem. And I'll close with this. Recall this slide from the start of the presentation, Sarah Drasner's illustration of how we should think about developer experience. This sort of holistic journey, the kind that prioritizes the intersections of developer touchpoints, that's the guiding principle for so much of what we do. And that's what we mean when we say that Go is more than just a programming language. It's an experience. And that's it. Thank you.